So let's start. The authors and invited guest, welcome to the technical session 4G. Myself Siddesh Mughal and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box. So just before we start the session, I would like to introduce you all to the chair of this session, Dr. Supriya Sabale. Dr. Supriya Sabale is an assistant professor at MIT Academy of Engineering, Pune, specializing in computer engineering IT, known for her work in artificial intelligence, machine learning, and deep learning, with multiple research papers and often associated with the computer engineering department at MIT AOE. She is an active researcher and faculty member at the college, contributing to its academic profile, particularly in core IT areas. Ma'am, do you have any opening remarks?
Yes. Firstly, good morning to all and one. A very warm welcome to all our respected dignitaries, distinguished speakers here, researcher and industry professional, and my dear participants. It's truly an honor for me to be here today as a session chair, and I would like to sincerely thanks to organizing committee of ICTCS 2025 for the kind invitation and opportunity to contribute to this prestigious international forum. Actually, this session has been envisioned to the both, I think, educational as well as inspirational, a platform where innovative ideas like a cutting edge research and practical experiences, uh, this all insight shared here will not only give us enhance our understanding of emerging technology, but it help us for defining a clear roadmap for sustainable growth. So I think is ensuring that technological progress remains inclusive, ethical, and environmental responsible. So I encourage the all participants to engage actively and exchange the ideas freely, and take a full advantage of this platform to expertise present here and let us this opportunity to learn from one another and to actively envision the solution that can create a long term and value for the society and industry alike. With this word, I once again express my gratitude for invitation and warmly welcome you all to this session. I wish everyone all the best and experience at the ICTC 2025. Thank you.
Thank you, ma'am. Let's moving further. Yashvi Shah. She is presenting energy profiling of NAS and traditional AI models for edge interference on Raspberry Pi. Do
Hello,
we have Yashvi Shah?
am I audible?
Yeah, you're audible, ma'am.
Yeah, I'll
You,
be sharing my screen.
yeah, you can share your screen now.
Yeah, now is it proper?
Yeah, you can start.
Yeah. So, good morning, respected session chair and fellow presenters. I'm Yashvi Shah, and today I'll be presenting on the paper titled Energy Profiling of NAS and Traditional AI Models for Edge Inference and Raspberry Pi. So, today, artificial intelligence is no longer confined to large data centers. It is increasingly being deployed on edge devices from smart cameras, wearable sensors to medical devices and autonomous systems. While the shift improves latency and privacy, it introduces a critical challenge that is often overlooked: energy consumption. Edge deployment offers advantages like reduced latency, improved privacy, and independence from network connectivity. However, these benefits become come with constraints like limited compute power, limited memory, and limited energy availability. So, this study performs a comparative evaluation between traditional and NAS models deployed on Raspberry Pi 4B, analyzing metrics like accuracy, inference latency, energy consumption, and carbon footprint using TC66C USB monitor for hardware and Code Carbon for software, which measures carbon carbon uh, carbon footprints. So, literature review. Traditional DL architectures like CNN and RNN achieved high accuracy, but they are resource intensive, making them unsuitable for edge deployment. While NAS models, which are dependent on auto ML techniques, they automate network design and optimize trade-offs between accuracy, latency, and energy. Early approaches like DARTs use the gradient-based search. FBNet and HANA incorporated hardware-aware optimizations. And there was many such strategies using reinforcement learning and various other methods for uh, making such NAS algorithms. Sorry. So the research gap that we uh, could find out was that there was a very limited real-world energy profiling across diverse NAS models on Raspberry Pi 4B, and there were like discrepancy between the proxy matrix and actual energy consumptions related to India. Like they were usually based on US or some other research-forward countries' energy consumption. May- Uh, and then there was limited focus on carbon emissions in edge AI deployment, lack of consistent and standardized profiling methods for Raspberry Pi 4B. So, our problem statement is despite growing advancements, AI deployment on edge devices still faces key challenges in computational cost and power consumption of traditional models, lack of standardized hardware-aware evaluation for energy and carbon profiling, and difficulty in selecting optimal models that balance accuracy and sustainability. So our goal was to compare traditional models and NAS models on Raspberry Pi on the basis of framework, accuracy, energy consumption, latency, and carbon emissions. And we could identify more sustainable or a better model for AI edge inference. So this was our flow diagram for methodology. We started our work on Cifat and dataset, and the dataset was raw dataset. Then we unpickled the files, reshaped it, and converted it into a PyTorch or a TensorFlow dataset format. Then the dataset was split into train, test, and validation sets. And then for ease of working, we converted them into number arrays and created data loaders. Then we also applied data transformations like resize, flip, normalization, and horizontal random flip. After that, the model training starts, and for both traditional models and NAS models, and at that time the measurements for carbon emissions and energy calculations is done for per batch. After that, the training and validation metrics are performed and the best model is saved. Once the best model is saved, we convert it into a lighter format. Like for PyTorch, we convert them into Torch script. And for TensorFlow, we convert them to TF-Lite. This was done so that they could be easily deployed and inferred on the Raspberry Pi for edge inferences. And once it was deployed on a Raspberry Pi, we used our hardware TC66 logger to check for energy consumptions. The data set was split into 40,000 for training, 10,000 for validation, 5,000 for testing on local devices, and 5,000 for testing on Raspberry Pi. So these were the models we used. VG16. So the core idea behind this is it uses a stack of very small convolution filters throughout the network, increasing the depth to maintain simplicity and uniformity. It has 16 weight layers, which are 13 are convolution layers and 3 are fully connected layers. The next was less than 50. So the main reason of using Resnet 50 and not Resnet 18 is because Resnet 18 wasn't available on TensorFlow and it was just available on PyTorch. So we wanted a comparative study. There's a reason we chose Resnet 50, and it uses residual block or skip connections, allowing training of extremely deep neural networks by directly passing the input to a later layer. And this mitigates vanishing gradients problem. Next, we tried was Inception V8. It uses Inception module to perform multiple convolutions of 1 cross 1, 3 cross 3, and 5 cross 5, and also does pooling operations in parallel. It concatenates the outputs. This allows for efficient feature extraction and representation learning. We then use DenseNet. The model was DenseNet 121. It introduces dense blocks where every layer is connected to other layer within the block via concatenation in a feed-forward manner. This promotes feature reuse and helps elevate the vanishing gradient problem. SqueezeNet, this model focuses on explicitly having very few parameters while maintaining competitive accuracy, making it ideal for deployment on edge devices. It aims to achieve AlexNet level accuracy with lesser parameters than AlexNet. So for NAS models, just to give an introduction what are NAS models. So they are neural architecture search models. It is an automated method to design neural network architecture instead of manually creating them. Traditionally, human decides the number of layers, filters, and kernel sizes. This process is slow, heuristic, and often hardware agnostic. NAS replaces this manual method with a systematic optimization procedure that searches for the best architecture under given constraints. So, in simple terms, NAS treats network design as a search problem rather than a handcrafted process. So, for NAS models, we use MNAS 50 and MNAS 100, uh, two versions. So, the core idea of MNAS, which stands for Multi Objective Neural Architecture Search, is where the search controller optimizes for accuracy and latency by integrating real world device latency measurements into the reward function. Then we use FVNet V3B and V3D. So B and D are basically the versions of FVNet V3, and it adopts differentiable NAS search strategy that replaces the discrete search space with a continuous one. It allows efficient gradient-based optimization. After that, EfficientNet B0 was used, and in EfficientNet B0 is a powerful scaling method that uniformly scales network depth, bits, and input resolution using a single compound coefficient. After that, MobileNet V3 large was used. It is a lightweight CNN designed for efficient inference on embedded devices, building upon its predecessor, MobileNet V2 with specialized blocks. And similarly, MobileNet V4 convolution small was used. It is a generalized architecture unifying previous MobileNet models by introducing automated block selection and compound scaling with hardware-aware optimizations. So, now deployment on Raspberry Pi models once were trained on GPU, specifically NVIDIA H100 GPU, and then once they're trained, they were optimized into TorchScript file for PyTorch and TensorFlow Lite for TensorFlow models. After that, they were converted to Inted optimizations for like making the models lighter. This was our setup. This is the Raspberry Pi, and just a sec.
Sorry to interrupt you, ma'am, but your 9 minutes are over. Kindly wrap.
Okay. So yeah. After that, we also introduced OFA method. So basically, we once trained a single large super network, and then generate smaller specialized subnetworks. So which will help it work on different hardware devices without training repeatedly. This is the OFA thing. And on the results part, so we could see that traditional models with PyTorch framework trained on NVIDIA GPU. This is the training accuracy versus training accuracy and training loss parts on the NVIDIA GPU. This is the validation, accuracy, validation loss, energy, and cumulative energy usage. This is for NAS, for PyTorch, and I'm just running through it. To conclude, traditional models like Denser and Inception remain accurate but power heavy. SqueezeNet has less accuracy but consumes low power. FNet V3D, MNAT 100 and EfficientNet B0 showed balanced trade-off between accuracy and energy efficiency, maintaining stable validation loss with significant low power usage. OFNX network framework successfully demonstrates train once, deploy anywhere adaptability. The results validate that hardware-aware NAS structures are ideal for embedded AI due to their sustainability and low power usage. On the Raspberry Pi 4B, energy and carbon values are marked lower than on GPUs due to reduced compute, but accuracy also decreases for certain NAS models. On Raspberry Pi 4, MNAT 100 for NAS models and SqueezeNet showed most energy efficient behavior by consuming very less power and carbon. It also retained consistent inference energy. To conclude, the findings illuminate that hardware-aware NAS models are optimal for low-power embedded AI applications as they achieve sustainability without compromising on performance. Thank you.
Hello, Yashashi. Am I audible?
Yeah.
Okay. So tell me, why did you choose a Raspberry Pi as a target for Edge platform?
So basically, we did have several other options like NVIDIA Jetson Nano and Google Coral GPU, Google Coral networks. But Raspberry Pi was first of all easily available. It was very cost effective. Costed really less as compared to other modules, and for ease of working also. And also that Raspberry Pi actually consumes really less power, and on comparison to NVIDIA Jetson Nano and others. Yeah.
Okay. So how does your work contribute to the sustainable and green AI, artificial intelligence?
So basically, till now there was less research done on the carbon footprint generated by while training this model, and also while deploying or while inferencing from this models. So sorry, that is one of the uh, methods how it contributes towards sustainability. Also, we did dual testing. One was using code carbon library, and other was using NVIDIA SMI command, which sends every the power consumed by the NVIDIA GPU every second, and by using some energy formulas, we could decipher its energy calculations. So this was not done on a very large scale till now for NAS models and for traditional models.
Okay.
Thank you, ma'am. Thank you, Yashasvi. Moving next, let me share my screen. Yeah. So up next we have Chetna Patil. She is presenting fake news detection with multimodal approaches and LLM based verification. Chetna ma'am, are you there?
Yes, hello.
Yeah, ma'am. You can
Am
share
I
your screen.
audible?
Yeah, ma'am.
Yeah. So good morning, respected chairperson, reviewers, and the fellow researchers. I'm Chetna Patil, and today I'll be presenting our research titled Fake News Detection, Multimodal Approaches, and LLM-based Verification. In this work, we study how fake news detection has evolved from traditional machine learning methods to the modern multimodal and reasoning-based AI system, with a strong focus on real-world misinformation scenarios such as WhatsApp forwards in India. So fake news has become one of the most critical challenge in today's digital world. With the rapid growth of social media, information spread instantly, but verification does not. So study shows that misinformation spread much faster than factual information, mainly because fake news is often emotionally charged and sensational. In India, this problem is even more serious due to widespread use of WhatsApp, where forward message often containing political or social misinformation circulate without any form of verification. So, this situation clearly shows that manual fact checking is not scalable, and hence automated AI based fake news detection system are necessary. So, the motivation behind this research is the growing gap between how fast misinformation spread and how slowly it can be verified. Our objectives are fourfold. First, to review traditional machine learning and deep learning approaches used for fake news detection. Second, to analyze multimodal techniques that combine text and image. Third, to study fact checking and evidence retrieval using API and web scraping. And finally, to examine how large language model enables reasoning based verification rather than just a simple classification. So let's talk about the text-based machine learning approaches. So the early fake news detection system were preliminary text-based and relied on the traditional machine learning models. Support vector machine and random forest were widely used because they are fast and easy to interpret. These models analyze features such as word frequency and term importance. While these approaches achieve reasonable accuracy, they fail to understand the actual meaning of sentence. Means the issue with the traditional machine learning approaches is that they are able to understand the content only and not the context. So they cannot detect the sarcasm, context shift, or subtle misinformation. Thus, although machine learning models are efficient, they provide only shallow language understanding. So, the deep learning to overcome this limitation, researchers move forward towards the deep learning models. So, CNN are effective in detecting local patterns in text, such as sensational phrases commonly used in fake news headlines. LSTM, long short term memory network, process text sequentially and can understand sentence flow and context over the time. These models significantly improve performance but require larger dataset and higher computational power, which limit their scalability. So let's move forward to the transformer based model, especially BERT, represent a major breakthrough in fake news detection. Unlike earlier model, BERT read text bidirectionally, meaning it understands the context of word based on both its preceding and succeeding words. So this allows BERT to detect subtle semantic inconsistency and biased language patterns, leading to much higher accuracy. So unlike traditional machine learning approaches, the transformer-based model such as BERT is able to understand the context as well, not just the content. So it able to understand the sarcasm, the bias towards someone, or the sensational language. But it is computationally expensive and lack transparency in their decision-making process. So, despite strong text analysis, fake news is rarely text only. So, in the real world scenarios, misinformation often combines misleading text with images, such as old photographs reused with the false claims. A text only system might classify such content as real, and an image only system might also classify it as authentic. The misinformation lies in the mismatch between the two. So, this clearly demonstrates the need for multimodal fake news detection system. So as we can see in the today's world, as we see the in the WhatsApp forward, there is not happens that there is only headline in the forward. So it will be the combination of both, like the image and the text. So the multimodal approach analyze both text and image together. So one common architecture combines BERT for textual understanding with CNN for image analysis. So these features are then fused to detect the inconsistencies between the two modalities. So the clip-based model go a step further by embedding text and images into the shared semantic space, allowing better alignment and comparison. So these multimodal models consistently outperforms text-only approaches but requires a larger data set and more computational resources. So now let's move forward. So detection alone is not enough. Verification is equally important. Like if someone is saying that this information is false, then how can we trust them? So for that, fact checking system retrieve external evidences from trusted sources using APIs such as Google Fact Check tools, Noobs, and government portals. When API fail to find the relevant data, web scraping techniques are used to collect the information from a reliable news website. So hybrid approaches that combine API and optimized scraping method provide high accuracy while maintaining a real-time performance. So let's move to the LLM, large language model, introduce a paradigm shift in fake news detection. So instead of simply classifying content as fake or real, LLM extract the claims, compare them against the retrieve evidences, and generate the explanation. Models such as Gemini 1.5 Flash are particularly effective due to their strong reasoning capabilities, multilingual support, and low latency. So, thus, LLM transform fake news detection into explainable evidence-based verification. So, the based on our analysis, we proposed an agentic AI framework. So, the system accepts the multimodal input, retrieve the relevant evidences using APIs and web scraping, align content semantically, and finally perform reasoning using an LLM. So the output includes a final verdict, confidence score, and the human readable explanation, making a system transparent and user centric. So, despite advancement, several challenges remain. So, most benchmark datasets are outdated and do not reflect current misinformation trends. Like there is a lack of multilingual and region specific dataset, especially for India. Multimodal systems are computationally expensive, and LLM still face the issues like the hallucination. So, addressing these challenges is essential for building reliable real world system. So, let's move forward to the conclusion. To conclude, fake news detection has evolved from simple machine learning classifiers to the advanced multimodal and LLM based verification system. So, our study highlights that combining text, images, external evidences, and reasoning leads to more accurate and explainable results. So the future results should focus on multilingual dataset, efficient architecture, and trustworthy reasoning mechanisms. Thank you for your time. I'll be happy to take any questions.
Hello, Chetna.
Hello, ma'am.
Okay, so my question for you is, how did you handle a dataset bias and class imbalance? You are referring a dataset here?
Yeah, actually, ma'am, this is our literature review paper. So we have not yet implemented these things. So yes,
Okay,
but we have seen two data set, IFND and the Bharat Fake News Course. So these two data set are in so the IFND is in English and the Bharat Fake News is in Hindi and English both. They contain the images as well. So for
okay,
better training of like machine learning and DL models, we combine both the data set. So that the number of rows will be increased and there will be better accuracy
mm,
with the large rows.
okay.
Yeah.
So my second question for you is, what real world impact does your proposed approach aim to address?
Yes, ma'am. So as we can see in the today's world, like people trust more on the WhatsApp. Like if someone said some news that some bomb blast happens in Mumbai or
Mm,
in Pune, so people easily rely on it. Instead of verifying it from multiple sources, people just blindly rely on it. And there are some people who are unknown about the government portals, government news website, so we are basically providing them a WhatsApp bot. Using that, people can forward a news to our bot, and we can detect whether that news is true or fake. So people do not need to go to the website and search whether that news is true or fake.
okay, in a form of application, you are created a separate application
Yeah,
for
yeah.
that.
Yes, yes. The
Okay, okay.
Flask-based website. We are
And
planning.
how you, okay.
Yeah.
How do you define and distinguish of fake news, like misinformation and disinformation in your study?
So yes, ma'am. Firstly, we have used the ML and DL based model, which train on the fake news, like how the patterns in the fake news are there, if there are any sensational words or the tone of the fake news, and based on that, our models will get trained, and on the basis of that we can predict whether the news is true or fake. And secondly, we are thought of doing an LLM. Means what the LLM does is LLM search on the web, like the government fact checking website, and if it finds that news there, so we are providing the verification as well, like if that news is fake, then why this news is fake, because we have find that news in these websites, which are official government websites such as PIB, Boom, Alt News, etc.
Okay, thank you, Chetna.
Yeah, thank you, ma'am.
Thank you, ma'am. Thank you, Shedna. Moving next. Next, we have Ankita Bhatia. She is presenting generative AI in personalized learning, a systematic review of adaptive educational technologies and their impact on learning outcomes. Ma'am, you can start your presentation.
Yeah, is my screen visible?
Yeah, ma'am, it's visible. Just present it in a presentation mode.
Hello, Siddesh.
Yes, sir.
Yeah, ours is remaining actually. It's Sagar
Uh,
Patil.
yeah, sir. So we'll come back to you once the sequence has been completed.
Suresh, my audio was working now.
Yeah, your audio is working, sir. So
Yeah.
we'll complete the sequence and then we'll come back to you, sir.
Okay, thank you. I just
Yeah.
sorry.
Can I start?
Yeah, ma'am, you can continue. Sorry for the interruption.
No problem. Good morning, respected session chair, ma'am, and other participants. I am Dr. Ankita Bhatia from Symbiosis, Pune. Today, I'll be presenting a paper on the title Generative AI in Personalized Learning, a systematic review of adaptive educational technologies and their impact on learning outcomes. First of all, I would like to discuss why are we performing this study. So, as we all are aware that generative AI nowadays is transforming education through personalization. And also, it has been showing a rapid adoption, but fragmented evidence shows the learning outcomes. Now, we need to have a structured synthesis of its benefits and challenges. So, the whole purpose of doing this research is to identify and structure how it is benefiting and challenging the current educational era. Coming to the introduction part, as we all are aware that generative AI is a technology which is capable of generating innovative types of contents, and tools like OpenAI's GPT and similar other platforms are accessing massive data sets and billions of APIs to provide a personalized learning experience for an individual level. As we all are aware that the unique capability of this tool is to produce immersive and more interesting learning environment where it will help the learners to provide their intuitive prompts and then it can address those prompts accordingly. Not only the learning environment is enabling the learners to learn, but it is also supporting and offering the immediate feedbacks. So, coming to the research objectives of this study, the research objective is to achieve the following goals, that is, to explore the current uses of generative AI for personalized learning and to examine how Gen AI affects the learning outcomes. Also, it is to identify the benefits and challenges that comes with using generative AI in education. Coming to the literature review part, I'll quickly run through this part. As we all are aware that AI is based on LLMs and GPT-4 is now being implemented, but fast forward to it, now we have GPT 5.2 at our hands. AI based tutoring systems is also trending nowadays and there has been a lot of studies done on that, and it has come up that adaptive personalized learning support is too much demanding to match the individual demands of the students. Similarly, Gen AI tools are designed in such a manner that they provide bespoke learning material also, like it is helping educators as well as the learners also. So, which can be varied depending on the progress and levels of the understanding students. So, this is all bespoke customization provided by Gen AI. So, this is the summary table of what all literature has been done, and case studies also have picked up, like Coursera, how it is performing online learning platform, adaptive learning paths, and now they have integrated Gen AI to provide the enhanced student engagement tailored learning experiences. Similarly, we have other case studies of Khan Academy, Night Framework, ChatGPT in engineering courses, Duolingo, Squirrel AI Learning, Alta, and I Talk to Learn. So, similar columns are talking about their personalization levels offered to the students and the educators. Also, in the last column, it is showing its last two columns, it is showing its benefits and the challenges. Like, for instance, if we see for Coursera, it is enhancing student engagement and tailored learning experiences, but it is at the same time limited by the quality of data and the algorithms used. Similarly, for the basic chat GPT model, if we see, it is enhancing student support, but at the same time, it needs adequate guidance and training for its effective use. Coming to the methodology for the current paper, extensive literature was performed in Scopus and Web of Science. We have used the following keywords, that is Gen AI and personalized learning, adaptive educational technologies, and generative AI. And similarly, others are written like artificial intelligence, custom learning experiences, generative AI, and learning outcomes. So these were the keywords used. 275 articles were screened and thoroughly read, and as a result, 53 peer-reviewed studies were selected. Thematic synthesis across applications and impact and challenges were done. The inclusion and exclusion criteria is clearly mentioned in this table. This is the flow diagram of our methodology. Like we did the screening, we identified the relevancy of the paper. Full articles were accessed, and if they were meeting the criteria which were shown in the previous slide, they were taken. And as a eventually 53 articles selected for final review were assessed, as I mentioned earlier. So this is once again the research objectives, methodology and findings, contribution. Everything is stated. Now, as a result of thematic analysis, we have identified the key applications, that is the AI tutors and chatbots, adaptive platforms, that is Coursera, Khan Academy, Duolingo, and AI-driven feedback assessments and learning outcomes. So what impact have we identified on learning outcomes is that with the help of the Gen AI tool, it is able to impact the higher student engagement and motivation. Like individual are themselves making lessons more relevant and engaging. This is increasing their intrinsic motivation and timely feedback and a sense of progress, improved retention and academic performance. So it is also facilitating simultaneously their personalized pacing of learning new things, adaptive revision mechanisms, that is helping them better to understand and retain the concepts, and learning gaps are getting addressed properly. This in turn is improving their overall academic performance and improvement consistently. The third one is that these Gen AI enabled systems are scalable, personalized learning across educational levels. So, it is also delivering individualized learning experiences to large and diverse student populations by ensuring the consistent quality and personalization from primary education to higher education and then professional learning. So, there is no age bar in terms of the diversification. Now, this is something analysis of how generative AI customizes the learning experiences. So at the back end of their data log, it is also simultaneously keeping the log of the behaviors, how the student is asking the questions, and it is also helping them to create a history page. And accordingly, the machine is trained, and then their future answers are tailored accordingly. So it also helps you develop your behavioral mechanism. It also keeps the trace of what kind of questions and to what level you want the explanations. So the machine takes cares of it, generative AI LLMs, and it will help you giving your learning advantage in the subsequent instances. Now, as we have discussed about the benefits, there are also the issues which have come across while we were doing this study, that is the challenges and the ethics issue. The challenges what we have come across is data privacy and security risks, of course. So extensive collection of student data raises concern about the concept confidentiality, misuse, and unauthorized access. There are still at central level weak governance frameworks which is undermining the trust in AI enabled educational systems. There are also, we have come across the algorithmic bias and fairness concerns. Now, AI models are, means they are equally, ultimately, they are unintentionally reflecting the social and cultural biases that is present in the training data. And it is also leading to unequal learning opportunities and unfair, sometimes, assessment outcomes. The third challenge is the teacher acceptance and infrastructure readiness. The successful adoption depends on the teacher's willingness to integrate AI into pedagogy. Still, this has not been uh, observed in full fledged, and there is a limited digital infrastructure and training that can significantly hinder effective implementation. Coming to the contribution and implications, our paper has been able to compile and consolidated various evidences that is purely backed by literature of how generative AI research has been progressed in education. It has also been able to guide the educators like how they can integrate the generative AI capabilities into their current curriculums and pedagogies. It will certainly help edtech developers and policymakers also to take care of the ethical concerns and the algorithmic biases that has been brought in this paper. And also it highlights the that how much it is important to highlight the responsible and ethical AI adoption. So that's from my end. I'm open to questions.
Hello, Ankita.
Yes, ma'am.
Okay, my question is first, which generative AI model were most commonly used in adaptive learning kind of systems?
Ma'am, while I was pursuing this study, then I
Hmm.
GPT-4 was used.
GPT-4. And what
Yes,
are
ma'am.
the other different models?
Like, ma'am, there was a perplexity with its
Okay.
basic form, and there were some other AI tools like which were specifically tailored for a particular things like making the PPTs and Atlas.ai that will help in creating the infographics. So these were the learning tools that has been assessed.
Okay. So, how are LLMs different from earlier rule-based or ML-based kind of adaptive systems?
I'm sorry, can I come again?
How are LLM different from early rule-based or ML-based adaptive systems?
Ma'am, first of all, what I believe is that once you are starting for a particular search or you want to start with a particular learning, it keeps
Hmm.
on taking your data like what is your case, what kind of questions are you asking, what is the topic you are trying to study. So it creates a history log. And based on that, all the
Hmm.
subsequent responses will be based on the previous data log that has been captured and it has memorized. So this is a one of the biggest advantages of the current LLMs, like previous history has been
Okay.
recorded and the future answers will be drawn upon based on those history. So this is the biggest advantages we have come across.
Okay, what are the different types of limitations we face in a generative AI?
Different types of
Are
limitation.
you facing some kind of limitations while you are performing
Yes, ma'am,
this?
absolutely.
Yes,
Sometimes hallucinations we face that some answers which we believe to be correct are actually not correct, then we have to manually go and check it. So still now we are not in a stage to completely rely on those responses 100%. And the second thing is that basically if we are trying to pull out some graphics or maybe some tables or the things which is able to do implications part like we want to generate, so that we have to again verify and correct it step by step.
okay. Thank you, Ankita.
Thank you, ma'am.
Thank you, ma'am.
Thank you so
Moving
much.
further, up next we have Manjit Singh. He's presenting investigating cold start latency in serverless computing using uncertainty aware based random forest predictive pre-warming technique.
Hello, sir. I am audible.
Sir, you're audible, but your voice is very low.
Is it fine, sir? Now,
Yeah, it's fine now. You can start. It's visible, sir.
visible, sir.
Yes.
So, good morning to the session chair, the host, and all the researchers. Firstly, I would like to thank the organizers of the 10th International Conference on Information and Communication Technology for Competitive Strategies on ICTCS 2025 for giving me an opportunity to present my paper investigating cold start latency in serverless computing using uncertainty aware based random forest predictive pre-warming technique. So this is the outline for my today's presentation. First, I will talk about the introduction of serverless computing and its major problem, that is cold start delays. Next, there will be literature review done by us, which is then followed by the methodology which we have adopted for reducing the cold start delays. Then I will discuss about the results and finally the conclusion and future research scope. Now, starting with the introduction. Basically, serverless computing is a cloud execution model in which the cloud service providers dynamically manages the allocation and provisioning of the servers. So it doesn't mean that there are no servers. The servers are there, but the users don't have to manage them. The developer is only responsible for just focusing on the functions. So, serverless computing basically gives the responsibility of resource allocation, scalability, scheduling, and resource management to the cloud service platform. And the developer only focus on just creating or writing down the functions only. So, basically, this serverless computing gives the abstraction. Abstraction to the developer that it makes the deployment and scaling of application on the cloud environment very fast. So serverless computing together with this has many advantages, and one of them is the cost effectiveness. And this cost effectiveness come from the feature that is the scale to zero. But this scale to zero feature uh, creates a problem, that is cold start delay. So basically, what is the cold start delay? It is a delay which occurs when the functions are invoked for the first time or after a period of inactivity. So from this diagram, we can see that when a request for a functions comes here, then there comes a step, that is the container provisioning. Then there is runtime initialization. Then there is dependency loading, and then the function is executed. So basically, these three steps, that is the container provisioning, runtime initialization, and dependency loading. These steps are carried on every time the request arrives in the serverless computing, and these steps create the uh, cold start problems. So next, we come to the literature review. So basically, many approaches have been defined by the researchers to solve the cold start delays. So basically, the pre-warming based approaches are divided into three categories. So first one is the static pre-warming, second are the dynamic pre-warming, and third are the hybrid approaches. If we talk about the static pre-warming approaches, in static pre-warming, a fixed number of warm instances or containers are always maintained to handle the incoming requests. In dynamic pre-warming, the number of pre-warmed containers depends on the workload. These approaches basically predict the future invocations calls for a function and pre-warm the containers if required. And when we talk about the hybrid approaches, in hybrid approaches, we get the benefit from the static approaches and the dynamic approaches. Basically, we keep some containers already warm and then add the new containers that are expected to be needed. Uh, and next, when we talk about the other approaches that have been proposed by the researchers for solving the cold start delay, so here comes the machine learning based solutions. So basically, in machine learning based solutions, I have mentioned here three important techniques. The first one is the recurrent neural network based predictor, in which we predict the future invocations and the pre-warming scheduler determine the required number of pre-warmed containers. The second is the reinforcement learning, which is used to allocate resources and feedback mechanism used for making the better predictions. And third, we have taken in the literature reviews the reinforcement learning, which is used to discover the uh, invocation patterns, and it is also used together with the long short-term memory to predict the future invocation times. And together with the machine learnings techniques, some other specific solutions also been proposed by the researchers, and some of them are the first one is the function fusion. Function fusion states that if two functions are fused into single one, the cold start of the second function is removed automatically. Second one is the hot container, that is hot C. It is a container-based runtime management framework which is used to reduce the cold start. Third, which we have taken in the literature review, is the seasonal auto-regressive integrated moving average SARIMA, which is used to predict invocation request time, and prediction-based autoscaler and horizontal pod scaler is used to minimize the cold start latency without the consumption of extra resources. So basically, we have taken one the predictive pre-warming based approaches, second is the machine learning based solutions, and some other specific solution for the literature review. Next, coming on to methodology that we have used to reduce the cold start delay is here. In our approach, the cold start delay in serverless computing is reduced by combining the predictive pre-warming scheduler with the probability and the estimated variance. We use the uncertainty aware based random forest predictive pre-warming algorithm, which predict the invocation time of the function and also estimate the uncertainty. If the model is confident, it pre-warms the containers before the arrival of the request and then reduces the cold start. So here this figure shows that if the request comes here and the model is confident, that is our model URF model. If the model is confident, it will directly comes to the execution. So these three steps that were part of the cold start delay, that is container provisioning, runtime initialization, and dependency loading, these will not executed in this portion. So this is our model, that is the UARF predictive pre-warming module. Next, we come to the working of the model. The URF model is basically trained on the historical invocation traces from one lightweight function cold A and one heavyweight function cold B. So basically we have taken two functions here. One is the cold A function and another is the cold B functions. The cold A is the lightweight function and cold B is the heavyweight functions. The invocation traces were synthetically generated using workload script on the cold A and cold B functions. For each time window, the model outputs basically two things. First is the predicted probability PT and the variance prediction sigma square 2. And from these two, we calculate the uncertainty adjusted probability, uh, which is given by this formula, that is PUCB T equals to PT plus B into square root of sigma x square T. Excuse me. And the pre-warming scheduler then decides the number of the warm instances using the mentioned threshold rules. So basically, these are the threshold rules which shows that what are the number of warm instances that we are keeping to pre-warm. So wt equals to 0, 1 or k. So 0, that is scale to 0, it is done when PUCBT is less than the tau low, and it is set to 1 when the PUCB is greater than the tau low and greater than less than the tau high, and it is set to uh, k when PUCBT is greater than or equals to tau high. Here the tau low and tau high are the tuned manually in our experiments, and it is kept by the configuration, that is min warm less than WT less than equals to max warm. Here basically we have kept the min warm equals to max warm equals to 1. That is, we have here maximum and minimum warm instances we have kept in practical
Sorry to
set to.
interrupt you, sir, but your 9 minutes are over, so kindly wrap up.
Okay, okay, sir. Next, coming on to result and discussion. So we tested our function into three types. One is the cold start, second one is the hot start, and third one is the predictive pre-warm start. So in warm start, what we have done, that we have tested our experiment, tested our lightweight and high weight function in the sorry, in cold start we have tested the our functions cold A and cold B in the cold environment by using the feature scale to 0. That is, we have limited the resources to the 0. So this figure shows the cold start latency for function A, function B, and these are their comparison. Next, what we have done for warm start analysis, that we have kept one containers always warmed, and we have tested this function, and these shows the figure 6 shows the warm start latency for cold A, and this figure 7 shows the warm start latency for cold B, and this is their comparison. Next, when we talk about the predictive pre-warming analysis, so we invoked our function cold A, cold B at random intervals. The invocation requests are logged into a raw event file, and then these raw events are proposed to generate data set for our predictive pre-warming model. So here we can see that predictive pre-warm latency is shown in the figure 9, and predictive pre-warm latency for cold B is shown in the figure 10, and the comparison is shown in the figure 11. And this table shows the a summary of the latencies for cold A, cold B in the three scenarios, that is cold scenario, warm scenario, and the predictive pre-warming scenarios. Now moving on to the finally moving on to conclusion. From the result, it is clear that the URF scheduler makes the cold start happen much less often as they do with the default open fast behavior. By starting containers ahead of times, warm instances are more likely to handle the requests, which make the system more responsive to users, and the scheduler take into account both probability and prediction variance, which cut down on unnecessary pre-warming and makes scaling action more reliable. The results also confirm that the number of cold start and the cold start latency are decreased by 20% as compared to the baseline open fast behavior. In future, we will like to focus on improving URF model by considering variable workloads, automating the threshold adjustment, and using advanced machine learning techniques. And we would also like to focus on implementing our model with larger workload and heterogeneous function with multi-level environment. Thank you. That's all from my side.
Hello, Manjit.
Yes,
My
ma'am.
question for you: what input features are used to train the random forest model?
Ma'am, basically, when we have implemented our practical, so
Hmm.
we run the experiment for cold A and cold B functions several times. So
Okay.
we are running our experiment, and we are generating data set from the same approach, ma'am. We are not taking any external data set, ma'am.
Okay. How is the prediction model integrated with a serverless platform?
So ma'am, basically, I have used OpenFast, which is an open source tool, and open
Hmm.
source tool we have OpenFast used for the serverless module, and Docker we have used for the images, and then we have used Kubernetes for the orchestration tool, ma'am.
Okay. How does your system decide when and how instances to pre-warm?
Ma'am, we have used a random forest model for probability, and then from these probability we have just calculated the variance. uh, and if the model is confident, so it will perform the instances, and if it is not confident, ma'am, then it will not perform the instances.
Do you know about vanishing gradient problem?
No, actually, no, ma'am.
You don't know about it. Okay, thank you, Manjit.
Okay, thank you, ma'am.
Thank you, ma'am. Thank you, sir. Moving further, next we have Shailaja S. She is presenting TerraVision AI, an intelligent NLP-based framework for automated land information retrieval and document interpretation. Shailaja, ma'am, are you there?
Yes, sir. Am I
Okay,
audible?
ma'am. Yeah, you are audible.
Okay.
Yeah, ma'am,
Is
it's
my screen is visible?
yeah.
Thank you. Good morning to the Honorable Session Chair, fellow researchers, and participants. My name is Shailaja S. and I am here to present our research titled TerraVision AI, an intelligent NLP based framework for automated land retrieval and document interpretation. So, introduction part. Land administration system in India and in many developing countries are extremely complex, unlike standardized digital records found in the advanced economy. India land document exists in the high inconsistent economy. Documents such as FMB, sale deed, survey maps, etc. All following different templates, language, terminologies, and structure depends on the region. They may be in handwritten or partially handwritten, scanned image with noise, maybe in different languages and some legal terminology. These challenges make land verification extremely difficult. The motivation for television AI stem from a critical real world problem. How can we convert scattered, unstructured, complex land documentation in a unified, trustworthy, machine readable, and easy interpretation format? Manual verification of land records often lead to delays, inconsistent, incorrect interpretation, and false manipulations. This gap found the core research problem that TerraVision AI attempts to solve. So now research problem. Our core research problem can be stated as following. Existing land documents are heterogeneous in formats and semantics, making manual interpretation error prompt and time consuming. This is now unified AI model and can extract, correlate, and validate information across multiple land document to provide accurate insight to users. We identify three major we identify three major technical gaps: lack of automated OCRs for regional land documents, absence of domain specific NLP for land terminologies, missing cross document correlations. Our work addresses all these three gaps. System overview. TerraVision AI is designed as an end-to-end intelligent framework capable of reading land document using OCR, extracting key details using NLP, correlating information using knowledge graph, and generating a structured human-friendly output. Our architecture contains major components like document injection layer. Here, the multiple formats like PDF scanned images, handwritten documents, text-based documents are converted into OCR accuracy and will be analyzed. Next is OCR handwritten and recognition module. Here, deep learning comes and multiple languages will be trained to the model. So, this enables high accuracy even in poor scanned land documents. NLP based field extraction. This is one of the most innovative part of our work. We designed the domain specific NLP pipelines for extracting field like survey number, subdivision number, owner's name, area, land type, boundary, etc. These techniques are involves named entity recognition, part of speech tagging, regular expression pattern for formats like serial number 23 by 2b. It's an example. And example use case. Let me illustrate the system with a real world scenario. A buyer receives pata in Tamil. FMB sketch as a yeah, FMB structure sketch as a resolution scanned image. Sale deed mentioning border boundaries and legal clause. Traditionally, the buyer must consult multiple official surveyor and legal experts. But with TerraVision AI, all documents are uploaded. OCR extracts text from each document. NLP identify fields from like owner name, survey number, area, etc. The knowledge graph correlates the values. A consolidated summary is generated, whether owner details are matching, whether the area is consistent across the documents, whether the boundary is aligned, etc. These uh, these instant clarity will be given by the TerraVision AI. Then the experimental result. We tested our system using a dataset of mixed patterns, Tamil and English language related land documents. Key observations are OCR accuracy improved by 28 to 35% by pre-processing. NLP entity extraction accurate averaged 82 to 88% depending on the document type. Knowledge graph correlation successfully identified several inconsistent between the pair of document. These results demonstrate the feasibility of an AI-driven solution for land administration. Contribution of our work. Our research provides four major contributions to the community. A unified AI piped for heterogeneous land documents, a specialized OCR plus NLP model for regional language, a scalable knowledge graph for cross-document correlation, a real-world use case for digital land governance. So, finally, to the conclusion. To conclude, TerraVision AI offers an innovative, practical, and scalable approach to an age-old problem in land administration. By integrating OCR, NLP, and knowledge graph, our system transfers unstructured language document into meaningful insights. It has the potential to support government land department, real estate organization, bank verification papers, legal professionals, and individual buyers and sellers. We believe this work marks a significant step towards transparent and data driven land governance in India. Thank you for your attention, and I'm open to questions from the panel.
Okay. Shailaja, my first question for you is how do you handle a heterogeneous kind of document format, like some documents are in a PDF or some records are like a handwritten kind of records are there, right?
Yes, ma'am. Actually, in simple terms, this is gonna be exactly like a chat GPT, but especially for the land documents. How a chat GPT is working, if we give a photo, a copy, or a
Hmm.
scanned image or a text, it will answer for everything.
And it is
Same
also not
concept.
visible sometime in some documents, the things are not visible clearly.
Yes, ma'am. For that, we have an open source, particularly for analyzing these improper images, converting into a proper text. So we are completely are using open source here and a Llama model and integrating
Okay.
with RAG framework.
Mm-hmm. What are the challenges arises here due to the legal terminology and domain specific language?
Uh,
Do you
here
face any
actually,
challenges? Yes.
actually we have a challenge for our TerraVision AI gonna analyze documents. In particularly, as I am in Tamil Nadu, I commonly viewed a problem that land having double documents. It's
Oh,
illegal.
yes.
So
Yes.
uh, the original document will be in the government website. Illegal document will be in normal people's hand. Uh, we need to
Oh,
give the access to TerraVision AI to access a government portal. If we gave the access, then we can identify who are making these illegal works. So
yes,
land will
yes,
be
definitely.
safe. Mm.
Hmm. What are
That's
the
a problem.
different types of, okay, what are the different types of land documents are processed?
Uh, we have Patta, Chitta, FMB sketch, sale deed, EC.
Property card, RTC, land
Actually,
titles are
as
like,
actually we
yes.
are working in Tamil Nadu range. So right now we
Okay,
used these four documents.
okay. Thank you, Shailaja.
Thank you, ma'am.
Thank you, Shailaja. Thank you, ma'am. Up next, we have Ankita Bhatia. She is presenting Understanding Investor Resistance to AI-based robo-advisory adoption, a perspective from an emerging economy.
Am I audible?
Yeah, ma'am, you can start.
Good morning, respected session chair, ma'am, and other participants. Today I'm presenting my second paper, that is Understanding Investor Resistance to AI-based robo-advisory adoption. So, what this is all about, basically AI-based robo-advisory services. Like we have human financial advisors, the next came robo-advisory services, which was algorithm-driven based platform in which investor profiling was used to be done. Like you have to give certain answers to few questions, and based on that, your profiling will be created, your risk appetite will be judged, and a portfolio will be recommended to you. So this was a traditional RA-based services. Now then came AI-based robo-advisory services in which there is nothing but artificial intelligence was integrated. When I talk about the introduction, it was the two US firms after major great financial debacle of 2008, that is Betterment and Wealthfront, that commenced the services of robo advisory, and after that, like it was globalized and implemented in various automation automated forms in different countries. However, the automation level pertaining to all the countries varies depending on how much automation has been inculcated in the platforms in that particular country. So this is all about the RA services and AI based robo advisory services. Why this study has been done? So the core research question is that why do investors in emerging economics like India are still resisting adopting the AI-based robo-advisory services despite their potential to enable environmentally sustainable financial advisory systems? So the core aim of this study to understand that why this adoption is being still at the lower stage based on the literature that we have identified, the adoption rate is still at the lower stage. Now, here is the clear distinction of what traditional advisor, robo advisor, and AI based robo advisor means. So, I'll typically highlight what actually AI based robo advisory services is. It is fully digital with AI intelligence. It is completely AI and machine learning driven. It is 24 cross 7 real time advisory and highly personalized to provide bespoke services. It also reduced biases via data driven logic. It is very high mass scale reach that it can simultaneously address the large scale investors, large amount of investors concerns. It is also continuous AI based monitoring system. So this is all about the AI based robo advisory services. Now, these are some of the studies that have tried to understood why the adoption rate of such services are very low, specifically in emerging countries like India. So these are the uh, studies, and this literature is also talking about what kind of models had been adopted to study these kind of research questions like time, UTAT, ECT were some of the theories that had been used to understand the behavioral intention to use RA services. Now, dual factor theory, which we have used in our current study, had also been used earlier to understand different kind of fintech systems, to understand their intention, like AI-based voice assistants, UPI payment systems. So this theory has been well tested in the context of AI-based systems. So that's why we also have decided to adopt the dual factor theory and to understand the behavioral intention to use AIRA in our current study. Now, the research gap and objectives. Existing studies have emphasized more on UTAUT, TAM, and ECT. That's why our study has employed DFT, that is dual factor theory, to bring in the novelty. Second is very limited studies have focused on the resistance and inhibitors to understand the behavioral intention and resistance of investors to use these services. And third is the objective of our study, that why how inhibitors shape the behavioral intention. We always talk about different factors that are certainly enablers also, but in our study we have explicitly focused on the inhibitors. Now, the methodology to pursue the current study was quantitative study, and it is a cross-sectional survey was done. SEM version 24 was used to perform the statistical analysis, and investor responses were taken majorly from emerging country like India. Sampling technique used was non-probability sampling to select respondents who were most relevant to the research objective. This is the conceptual framework of our study. We have taken inhibitors as switching cost, perceived risks, and lack of awareness. These we have arrived at these inhibitors purely drawn upon the literature review. These are the uh, these are framing or shaping how these are framing or shaping the behavioral intention to use AI-based robo advisory services. Now, as I have already mentioned that these inhibitors are actually relucting the investors based on the literature to use the AI robo advisory services. So our hypothesis is designed accordingly that these are negatively influencing the behavioral intention to use AI-based robo advisory services. We have also tested at the same time the moderating role of gender on these paths, like how these inhibitors are shaping behavioral intention according to the gender. So this is the hypothesis formulation table. This is our SEM path structure analysis diagram that we have performed. R square is 72.6%. That means all the factors are actually explaining very well the behavioral intention to use AIRA. Here it is also showing the moderating role of gender. This is the table. All the factors, that is switching cost, perceived risk, and lack of awareness, are significantly negatively influencing the behavioral intention to use robo advisory services. These are the decisions that the hypothesis are supported, and these are the this is the moderating variable, and the decision of that is also supported, except for the lack of awareness. That lack of awareness is found to be playing the same role between the male and female. This is the model fit indices which we have received. Our model's NFI is 0.8, that is fairly acceptable model. The model fit is okay. The key findings of our study is that all inhibitors are significantly influencing the behavioral intention. As per the stats we have received, PR and switching costs are the dominant resisting forces, and awareness also plays a foundational role in intention formation. Contributions and implications of our paper is that it shifts the focus from adoption to resistance. It also extends DFT in robo-advisory context, and it also provides practical guidance for fintech firms and policymakers. Now, paper's contribution is that it actually provides a practical roadmap to redesign the onboarding process by critically understanding the inhibitors and to reduce the measures which is actually making the investors to resist to adopt these services. Secondly, the studies have also provided some gender sensitive managerial insights that it is impacting the switching cost and perceived risk. So, to target or to tailor that, a targeted communication and educational strategies can be adopted to address this, though, so that they should be practically able to make the trust building mechanisms that are far more effective for female investors because these resistance were found to be more dominating amongst the female investors as per studies. Third, for the policymakers and regulators, especially in the markets like India, the results underscore importance of financial awareness, and there is also a lack of awareness of regulatory backed literacy found amongst the respondents. So that can also be accelerated to exhibit the responsible adoption of AI-driven advisory services. Thirdly,
Ma'am, sorry to interrupt, but your time is over.
just a last slide because this is a very important slide. How this is contributing to the sustainable environment, like by reducing the physically going to offices of financial advising operations. This will operate digitally if we're able to overcome these resistances. This will lower the paper consumption and energy uses and carbon emissions also. Second is that particularly SDG 12 and SDG 13, that is responsible consumption and climate action, can be minimized resource with the maximum outreach and increased adoption of AIRA services. Dependence on high cost, high resource financial intermediation models contribute to greener financial ecosystems. So that's all from my side. Thank you. I'm
Okay.
open to questions.
Hello, Ankita.
Hello, ma'am.
Your question. What
Yes.
specific gap you identify in a existing fintech or behavioral finance literature? Does your study addresses anything gap in between
Yes, ma'am. So
this?
whatever studies have been done so far in terms context of fintech adoption, that were
Hmm.
mostly targeting the factors, those were enablers. Like none of the studies had been done previously, like what is actually, what inhibitors are actually impacting behavioral intentions of investors to use this robo advisory services, those which are forming the positive mindset. But in our study, we have actually identified the factors which are not forming the positive mindsets and that are actually relucting, like switching cost, perceived risk, and lack of awareness. So we have tested those.
Okay. Did you ensure about the reliability and validity of the measurement scales?
Yes, ma'am. So we have performed SEM, and in our
Hmm.
full report, Cronbach sulfur, composite reliability, everything was taken care of, and they all were above the threshold level of zero point 0.7. Even average variance extracted of each construct was greater than zero point 0.5.
Okay. You are implemented this. You are getting some result for it.
Result, yes, ma'am. I have shown that in my slide also.
Okay.
The
Okay. That.
conceptual
So
part is there.
sample selected and what kind of sample size you are referring there?
Ma'am, sample size was not that too large because still I
Okay.
did it as a part of the pilot study. So the sample size was close to 170, and I used the judgmental sampling technique, like those who were aware about it and those who had already used basic RA services like robo advisory services or any kind of digital automated apps to do their investments.
Okay. Thank you,
Yes.
Ankita.
Thank you, ma'am. Thank you so much.
Thank you, ma'am.
Thank you, sir.
Up next, we have Ritik B. Saraswati. He is presenting underwater object detection. Do we have Ritik? I guess we don't have Ritik. Okay. Moving further, do we have R. Hitesh? Do we have Aritesh? I guess no. Uh, Sagar Patil? Dr.
Yeah,
Sagar? Yeah.
yes,
Yes, sir. You can continue with your presentation. You're presenting detection of lung disease through application of machine learning algorithms with transfer learning, right?
yeah, yes. Let me share my screen first.
Yes, sir.
Thank you for giving a chance to present my paper uh, on detection of lung disease through application of machine learning algorithms with transfer learning. So myself, Sagar B. Patil, and along with my other colleagues. So the first thing is, rather than starting with what is the challenge, let me go through why we chose this particular topic, and then we'll come to the challenges. Because we chose this topic as after the COVID, a lot of people are getting the diseases or the illness related to the lungs. So there was continuously a lot of study was going on in the field of lung diseases, and there are a lot of challenges also. And due to the help of our computer science engineers, we are contributing a huge amount in early detection of these particular diseases. So that's the reason we chose this particular topic. And when we have gone through the literatures, we have found out the lot of challenges in this particular area, for the computer science engineers to look into it. Because the problem is the symptoms of this particular lung diseases are very rare, and it has to be scanned with lot of x-rays and all other kind of images, and then only we'll come to know about the particular disease. Whatever traditional practices the doctors were following, there were a lot of problem, and there was a challenge of the judgment, because it varies from doctor to doctor. So that was again the problem with not using the computer techniques. There are a lot of lung diseases covered, such as there are tuberculosis, COVID-19, everybody knows, lung cancer is there, pneumonia is there, and a lot of other health related or lung disease related uh, diseases are there, which are contributing in a huge amount for the illness to the particular uh, person. So how the machine learning can be used in this particular revolution is, rather than using the traditional approach of a doctor identifying it, we can use a machine. So machine enhances the accuracy of it. So that's one of the biggest advantage. The second advantage is it's involves, or it removes the manual work, and will go towards the automation in detecting this particular lung diseases at an early stage. So that's a third advantage, wherein we can detect the diseases in early stages. So these are the couple of advantages we have found throughout the literature reviews also. So that these two fields, medical and our computer science field, engineering field, come together to enhance the detection. So this is the framework which we have proposed, wherein we are using the images and database of lung diseases put into our application, and along with the patient registration happens for that particular applications, and then we detect the particular disease depending on our ML model, which uses a transfer learning, which has a couple of steps as mentioned here: pre-processing, segmentation, feature extraction, and classification, where exactly the lung disease will get classified, and then that will go to the web application which we have proposed. So as the methodology shown in a previous slide, patient registration happen first, then the patient will upload the images from his side, Then adaptive thresholding happens to those particular images because we want to isolate a particular disease, and then feature extraction from that isolated area happens. For that purpose we are using efficient net b3, and then after that the disease detection happens. So let me go through the data set. So data set, we have used open access data sets from the Kaggle. We have not generated it. It contains around 5856 images exactly. And when we use the machine learning and this transfer learning, we are using these hyperparameters with the dropout rate of zero point 0.1, ReLU activation function, batch size of 32, and atom optimizer with 30 epochs. Okay, so mainly we are using this particular model EfficientNet B3 as we have gone through the literature also, and in analyzed it with a couple of other models also. This particular model, uh, in accordance with the disease in the lung diseases, this particular EfficientNet B3 performs very well in terms of scaling. We used predefined coefficients as we have said. Then transfer learning, we have fixed some of the parameters, some of the layers, and we have modified, unfrozen the outer layers, which we can unfreeze and transfer the learning from the previous models. And when we analyze it, the balanced accuracy was very good in case of disease detection. So these are the results which we found with this particular model, that we got around 99% accuracy with only limited training images of 5856, and we have used four categories to identify these particular diseases, which identified in these four categories. As we have gone through the literature, the rest of the accuracies were in the range of 94 to 98. So in terms of accuracy also, we have achieved a better accuracy. We have designed web application also, wherein user can make use of this, upload an image if he has an x-ray and all, and in the png format or jpg format also is applicable, and then it get a detailed analysis regarding that particular disease. So this will be helpful in terms of finding out the disease in an early stage. uh, so in the conclusion, we want to say this approach involves the medical field and computer science field come together, and lot of predefined or pre-generated models can be used with the transfer learning for identifying the diseases. There are a lot of future directions, like the telemedicine is there, mobile applications can be developed for the same. One of the CNN and RN come together, and then the fusion architectures can be developed. And there is one concept called federated learning, so that also can be used to the improving the robustness of this particular thing. So, so at the end, I want to say that this particular medical field is getting transferred from the artificial intelligence and computer science, from the traditional identifying of the diseases to the personalized medical applications. Okay, these are the references I have gone through. There is a lot, I have put very few, and thank you. I'll be open for the questions.
Okay. Hello, Sagar. My question
Yeah.
for you, what are the different types of medical images data did you use, like a X-ray, is a CT scan or MRI?
Yeah, currently, actually, for this particular initial stage, we have just used X-rays, for the identifying it,
Okay.
but we can enhance it to
CT
rest of
scan and
the.
MRI, because
Yeah.
if you are getting the better result, you have to use all kind of data associated with that particular lungs diseases, right?
Yes. 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 Yes.
So, can you tell me about which kind of specific lung diseases are targeted in your study?
Yeah, so actually, we have got this data set which is freely available from the Kaggle. So we are just following these four types, you can say. One is healthy, and another one is rest of the three are COVID 19, pneumonia, and tuberculosis. So these are the four categories
Okay.
we are targeting.
And major challenges in automated lung disease detection. Are you facing any challenge?
There is a bigger challenge actually in the field of this is X-ray images. When we because we are using very small data set, we can say 5,800 plus images. So the
Hmm.
biggest challenge is once we augment this particular data set, uh, we have analyzed it or we have seen that the model behaves little bit differently. So there are a lot
Are
of
you trying for collecting any kind of real-time data which is available at a hospital, like a
not yet,
large
but
kind of?
yes, not yet, but definitely in the future we are trying to get a real-time data wherein we can work on real-time data. Even if we have compromised on accuracy, that's not a problem. But actually, we want to work on a real-time data.
Yes, yes, obviously. Okay, thank you,
Yeah,
Sagar.
thank you. Thanks a lot, ma'am.
Thank you, sir. Thank you, ma'am. Moving further. So next we have Kapileshwar Reddy, Siddhi Reddy. He is presenting efficient utilization of dynamic RAM using a synchronized SDRAM controller, FPGA implementation with VIO and ILA methods.
Hi, Siddesh, am I audible?
Yeah, you are audible, sir. Now
Yeah.
you can start.
Okay, without further, I'm going to present it. Minute.
Yeah.
Hi, and good morning, everyone. Hello, panel members and all. My paper was based on the efficient utilization of dynamic RAM using the synchronous SDRAM controller. That is the baseline of my paper, and uh, my outline, today's outline for this presentation was coming starting with the introduction and motivation background and proposed work architectures and verification methodologies and how it was evaluated using in the results and conclusion and future works of my design. And without any further, when we are going to um, the introduction, the DRAM, dynamic RAM, and static RAM, we have usually when it comes to the memory designs, we have two types of RAMs, which is dynamic RAM and static RAM. Um, and which are like a volatile in nature, but my aim to design was a non-volatile memory which if you even turn off your device after, even though if you that memory won't disappear once you turn out, it will be start from that whenever you stopped it. And by I mean you normally designers make the SRAM, DRAM and SDRAM also, but my what I did was make it more controllable when it comes to the timing part. How it was looks like, usually I'm a hardware engineer. I mean, I was doing the how to control my timing as much as possible. Usually, SRAM will take six transistors, and DRAM will take one transistor, one capacitor, and SDRAM take one transistor, one capacitor, which is equal to DRAM. With the less number of hardware usage, we are making our design as much efficient as possible. And when it comes to the refresh, in memory, we use the refresh, pre-charge, these things to check our data flow, the data which we are flowing from the source to destination is proper or not. Is there any miscarriage happened? Is there any mis usage of the data happened? They will check each and every step by step. So for that, we use the refresh and pre-charges, and it was and our main aim is to make it as it was working in time or not. So for that, I clocked my design as much as possible. And burst mode is for continuous transferring the data without any issues in the middle. So and control complexity was high in my design compared to the normal and traditional SRAMs or DRAMs. SRAM means static RAM, DRAM means dynamic RAM, which is in name itself, it was works. SRAM was works statically and DRAM works dynamically, and it was those two are, I already told you, it's a volatile in nature. If the design once, I mean, which once the device was stopped, the data watch inside it will be gone. Nowadays, each and everyone looking over the non-volatile memories like resistive random access memory, magnetic RAM, these kind of non-volatile memories. So I use those techniques to improve my design, and for that I strictly use the timing constraints like TRCD, which is a row column delays, and pre-charge timing, and cache latencies to, and periodically refreshes my design. This is the basic outline for my design. And when it comes to static okay, this is my design which I implemented uh, in a system Verilog model, and which is fully controlled by FSM, finite state machines. My commands, each and every commands, which sequentially controlled by the finite state machines. It's a process, step by step process. It works like, how to say, I mean, like a traffic controller. Once the red the format will be there, no? Like that FSM will work. Once one command will be executed on time, according to that command, next command will be activated. Like in this um, block diagram, you can see once the initial stage will activated, then only that pre-charge, refresh, and one by one it will go. So it's like a pre-designed each and everything as much as possible. And my internal blocks majorly constructed with the logic, my design logics, and address decoders, which consists of bank, row, and column, each and everything, and commands of FSM generator and STRAM timing controller and refresh scheduler and read write paths. It is a bidirectional range. It will do read and write parallelly at the same time. And this is my VIO. VIO means virtual in-out port. I use the FPGA board, which is Jinx 7000 board. This is the Jinx 7000 board. In my design, I have more than hundreds of in-out ports. So this jet board was inefficient for that, to take those many inputs and outputs to show my results. So I use the techniques called VIO and ILA. VIO and ILA techniques. And here, this VIO mainly drives the read-write enables and addresses inputs, observes the controller states of the data. It mainly works on the how data was transferring from the one place to, mainly focused on the commands and addresses and the data. Usually data will be when we are transferring data from the source to destination, the data bits consist of three breakages: header flit, body flit, and trailer flit. Flit will take care of the source to destination, how it was flowing, and the body flit consists of our main data, our main body, and trailer flit will tell us about if any leakage or if any drawback in the data. It will immediately it will activate that, and it will show us like there is a mismatch in the data, so check it like that. When it comes to the ILA models, in this ILA models, it's already I gave some I mean, what are all the inputs, what are all the outputs to my data. In this ILA model, my inputs acts as an output, outputs as an input. If it's like a back propagation in AI. So according to that, it will back propagate and it will show where it was came from, like that ILA model. It mainly works on the uh, verifying the timing, verifying the data. And these are all the my waveforms which I captured from the Vivado model, Vivado tool, which is the Xilinx AMD. So here it will show my input data was 24 bit, 0 to 23 bits for just for the data, and row address, column address, these are the consist of 8 bits. So using this for the 24 bits of data, I can make nearly my memory to 16.7 billion million combinations, million combinations. And when it comes to the address rows, I can make 65,000 to, sorry, 536 locations. I have those many locations and these many combinations. My total data transferring range and total combinations will be near to the 4.2 billion. Because a combination of these, I mean 2 power 32, 2 power 32 combinations I can do, which is approximately equal to 4.29 billion. And these are the here in the first I gave this is the static, I mean the very first waveform I got. And here you can see read data was not enabled. It was in the X, it's in meta stability state. After that, in the second phase, when I activated my functions, here the read data was active and it was reading the data, and it was reading again and again and again after time being. And I have the write burst also. And according to the design, according to my commands, the memory will be as allocated. It's a memory was same, but the controller was different. It mainly works on the timing. And what I achieved from these was finite state mission based verilog implementation, system verilog implementation, and efficient usage of logical units in flip flop usage, and non-vendor specific memory, and IP dependency protocol across the FPGA families. I use the FPGA family called Jinx 7000 evolution board, and this is the my main diagram which I got from the tool called Xilinx XDC. This is my code, and out of I have nearly 303,600 LUTs. Out of that, I just use 104 LUTs for my design. Just one
Sorry
of
to interrupt you, sir, but your 9 minutes are over.
Okay, I just wrap it out. Okay, now when come to I design and implemented a efficient SDRAM controller abstract with the proper SDRAM controller with the SRAM like interface supports the transfer, the automatic refresh, and verified through the FPGA boards using VIO and ILA techniques. And my future works are latency optimization, throughput tuning, and error correction and fault tolerance, and DDR4, DDR5 controllers, memory controllers can be extended to. Yeah, yeah. Thank you. And, I'm looking
Okay.
for the.
Hello, Kapileshwar. My
Hi,
first
ma'am.
question for you. What are the
Mm.
key challenges in implementing a SDRAM controller on FPGA?
My key challenges, ma'am, there is no sufficient inputs and outputs I have on that board, ma'am. I mean, whatever board I was collecting, whatever from the sources, I nearly
Okay.
changed 5 boards. Vortex, Patron, Jet board, these all these things. I never ever get across my inputs. So I just tried and hard, and I found this ILA VIO methods. It is like the system will run in the board, and but the output will, I mean, it's like a software hardware combination. When you gives the
Okay.
run, it will goes to the
Hmm.
board will run it, and it will give a back to the software, our PC or our laptop, and it will show it here. It's a
Okay.
hardware, it will run in hardware, but it will show in the software.
Software. Okay.
Yeah.
So, how does your approach to improve the memory utilization and efficiency?
Yeah. My approach was usually when it comes to the refresh stages, pre-charge stages, no, most of the data was collapsing, and you need to check each and every time. So I nearly have more how to say,
Okay.
we
How
I
does
nearly
your
have.
design, how your design improve the memory bandwidth utilization here?
Yeah. Actually, I mean, I reduced the command stages. I have nearly 12 commands. I reduced to 6 commands, and each and every time, while I reduce the 6 commands, no, automatically my timing variant will change. And this design bandwidth was 2 power with the bits of 2 power 24 bits, ma'am. So
Okay.
and here you can see it's a hardware design. No, I use one transistor, one capacitor SDRAM type.
Okay. Thank you, Kapileshwar.
Yeah.
Thank you, sir. Thank you, ma'am. Moving further. So this was our last presentation. Let me start my, yeah. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through emails within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team ICTCS 2025. Share my screen. Yeah. So I sincerely thank our session chair, Dr. Professor Supriya Sabale, for chairing the session. A token of appreciation to the chair on behalf of Team ICTCS 2025 and Global Knowledge Research Foundation and partners. Ma'am, do you have any closing remarks?
Yes, I have.
Yeah, good.
Wait. So, as we come to the conclusion of this session, I would like to express my sincere appreciation to all your distinguished speaker, presenter, and the participant for making this session really truly enriching and impactful. So, this session and presentation we witnessed today have highlighted and transformative role of information and communication technology in driving a innovation, strengthening the strategies, and enabling the sustainable growth. So, this diversity of ideas shared from the theoretical advancement to the practical applications in some presentation has really reinforced the importance of collaboration between the academics, industry, and the policymakers. So, I would like to thanks the organizing committee of ICTCS 2025 for their planning and for providing us with a global platform to exchange our knowledge, ideas. Such innovative plays a role for nourishing the innovation and guiding a future research direction. So, as we move forward from this conference, I encourage everyone to carry this learning into the research, into the industry practice, and a policy decisions, so that together we can help shape and we work with a sustainable digital future, right? So, with this word, I formally conclude this session and thank you all for your active participation and all the best wishes from my side. So, thank you so much.
Thank you, ma'am. Thank you so much. I kindly request you all to switch on the cameras for a quick snapshot of the virtual conference. Thank you and stay safe.